Okay, all right. Today, here's what we're doing. We're going to talk about the types of lines, linear equations. Again, this is the last section of chapter 1 for us, and then we'll be looking at possibly as early as Monday start reviewing for the chapter test. Because I kind of warned you last week, or earlier this week, I should say, that we have a test as early as Wednesday next week, and that's pretty much the case because we're going to start reviewing Monday and Tuesday next week. And then we'll have our test on Wednesday. That way you have an extra week, because not next week, but the week after next week, that's the end of the quarter week. So like that Friday. So I want you to have at least 1 week if you want to retake, if you want to see what your score is, that type of thing. So I always like to do that. For me, cutoffs for grades and late work and whatnot, I want them in next Friday. Like all late work, if you have a missing, if you want fixes, all that good stuff by next Friday. That way you can at least see what your score is for sure, like definitively, this is my quarter score. Does that make sense? I don't like to leave people hanging like, oh, what's my grade? It's gonna be iffy by the end of the quarter. I want it done by next Friday. You have a week in advance, okay? Hopefully that helps you out. That way, anything we do that week of the dead week of like the end of the quarter, that just goes on the next quarter stuff. So I'll kind of warn you what assignment is the last one. So that kind of gives you the heads up what we're doing the next few days in here. We have the last section today, which is 1.5. This is the last section of it. Today we're going to do a quick introduction into it. The best part about this section, it follows exactly with what we were doing yesterday and the days before, talking about linear equations. But what this one is entitled, it's called More on Slope. More on Slope. And it basically discusses a couple key features of what slope is. So the big thing is, first thing I want to talk about is let's talk about what an average slope is. One more time, just to make sure you know how to find it, because you'll have to do that for your homework. You have to find slope a lot. We'll talk about the concept of it. There's a vocab word that I want you to know that would be kind of handy before you get to calculus, which is called the secant line. We've talked about secant lines in geometry. But I want you to make sure that's like a key word I want you to know today. But once we're through that, what we're going to be discussing with these types of things, we're going to discuss parallel lines, and we're going to talk about perpendicular. There's some vocab words that go with perpendicular. We'll talk about that today as well. So there's some more vocab here. Okay, so there's kind of our outline today. I'm not going to go the whole time. I'm going to try to go maybe 15 minutes or so. Give you the rest of the class. You can work on your homework, because I did give you a pretty chunky little assignment, right? 12 problems, you had a graph. Did anyone not receive graph paper from me yesterday, like you were gone and you didn't get one? Okay, I know that did you get graph paper the other day before?
I don't think so.
Why didn't you speak up, Abby?
So, anyone else need graph paper for that assignment? You only need one page. There's 12 problems, there's 12 exact graphs. I don't know if all of your homework can just fit on here, because there's some that you have to write the equation down. I don't know if you have enough space.
Yeah, you
might. Okay, you might need a second sheet of paper, but there you go. Use pencil on this assignment. Don't use pen, because if you make a mistake, you only get one. So if you make a big mistake, it's okay to have it. Okay. Okay. Are we good? All right. First, let's get into the vocab terms. Let's talk about what average slope is. This is something that we've discussed a little bit before earlier this week, but it's kind of nice to review it just so you know. Average slope is the slope that you've done since Algebra 1 days, pre-algebra days. It's based on this formula right here. That m equals y minus y, x minus x. That's average slope. The reason I want you to see this is that I'm going to write this differently. And I want you to see the different look, even though it's the same exact formula, how they could write this. Let's imagine that I had an equation here, something like this. Let's say 3x plus 1. Okay, I think we've used that a couple times this week. That's a linear equation, correct? Doesn't have powers or anything on it, so we know it's a straight line. Instead of writing it as a y, they could write this as f of x. That's just the name of the function. It's the f function using x as a variable. But what I want you to see is how they could use that concept of like the f of x idea with that. And to find slope on something like this, if you actually had x numbers, so maybe they told you that your x is, one of your x is like x number 1, x sub 1 is let's say 5, and x sub 2 is an 11, that type of thing. You can actually find slope by just that information. And I don't think anyone's really kind of fully comprehended like what they're actually telling you there. They're telling you your two x numbers, and you can go find the y numbers that are attached to it. You can go, so this is 5 comma something, you can go find this number because they gave me the formula to start with. So what I can do is I can plug this 5 in here and actually find the value for the y number. So this number would actually be f with 5 plugged into it. It's the function with, and I just plugged in 5, so that'd be 3 times 5 plus 1, which is 16. So this would actually just be a 16 sitting there. Or I could plug in the 11, and that would be f of 11, which is a really big number. That's 33 plus 1, which is 34. So that's just a look. Some people don't really think you can do that. You can go find your y number, your own y number, and then you can immediately take whatever these two coordinates are and immediately go over here to this graph. And you can go find it. You can go find the slope and whatnot. We already kind of know what the slope is, but you can go find it for whatever problem you have. It doesn't have to be linear, it could be anything. But this is the look I want you to know. This is how they could write it. I know this is gonna seem really goofy. They can write the problem like that. That is the same exact formula as what you see up above. F of x sub 2, that's just a y number. F of x sub 1, that's another y number, so it's y minus y, and then over the x is being subtracted in the same order. Does that make sense, like the look of it, like what they're doing? They're gonna start showing you that in the book from now on for slope. It's the same thing you've been doing all week, this week. I don't want you to get confused with what they're showing you. It's just y number minus a y number, x number minus x number. Now, the reason why I bring this up is we're going to be getting into a point in this next chapter that we're not going to be just dealing with linear equations, right? I think you even had to do one with the little piecewise functions, 46, 47, 54. One of those had a curve to it. Well, we're going into polynomials which have a lot of curves. So you could have a problem that kind of mimics this, where there's just lots of things happening, or it's going up and down, it's going different heights. There's relative and maxes and mins. And the idea is that what an average slope is, it's called a secant line. That's a vocab word. A secant line is a line that you want to go through a function twice, whatever function you have. So a secant line would be something like this. You pick two coordinates, let's say this spot here and this spot over here, and you draw a line, a straight line that went through them both. That's a secant line. Why we would ever do that is that secant line can approximate what the slope is of the curve at that kind of location. That maybe you're trying to approximate what the slope is right here. That's called a tangent line. It's a line that just perfectly grazes it and goes kind of the same direction where the slope is going. But a secant line would kind of mimic that. You see how the two lines kind of look like they're somewhat parallel to each other? Parallel lines have the same slope. So that's why you could pick two coordinates that would kind of give you something very similar to that, and then you can find your normal slope formula. Now, why we want slope is it's called a rate of change, right? A rate of change is speed. It's a velocity. So like a civil engineer going north of Garner here would need to know the tangent or the slope of the curve, so they know the speed of your vehicle going on the curve. That's the whole point of it. So that's like the most broad definition of why we want to find slope. Slope is also used to predict numbers that happen down the road. Some people don't think about that. If you had a linear equation and you had two coordinates that you had that plugged in that worked, you can see them there, two dots that are on the line. You can predict where would the dot be 50 feet down the road. Where would this dot, instead of up to 12, what would happen at 50? Where would that dot be? Way up in the air, and you can predict that. because you need slope. Slope tells you, okay, you can rise and run, rise and run, rise and run, and you just keep doing that over and over and over, and you would eventually hit 50 something. All right, questions on what average slope is, like the concept of it. It's something you've been doing all week though. I mean, you know how to find slope. You just subtract the y number, subtract the x's. I'm warning you of that because of what we're going into. I'm warning you of that because of the questions I'm getting in Calc 1 from my students, that they just don't understand what slope is. It's just the tilt of a line. It's like the idea of like where a line is heading, like which direction it's basically facing, that type of thing. Okay. Any other questions on what average slope is before I move on? Just something I feel that you need to know. Okay, we're gonna use this concept, this average slope idea. We're gonna still use this. This is our kind of go-to formula, by the way. That's what we have. And I wanna go through an example of parallel and perpendicular. All right, let's talk about parallel first. I almost had a example better, but parallel lines. And we're going to be based in Euclidean geometry, if you remember that from geometry class. We're in two space, that type of thing. What do we know about parallel lines? What do you learn? What have you learned in the past? They never intersect. Okay, number one. They do not intersect. Not intersect. Okay, perfect. I agree with that. What else do we know about parallel?
They have the same slope.
Ooh, nice. They have the same slope. Anything else that we know? Those are good. Those are like the two. Say it.
Straight lines.
Okay, we gotta be dealing with straight lines. That's a key thing. Straight lines. We're not talking about curves right now. Straight lines, that was good. What else do we know? These are really good things. I'm actually impressed with you guys nailed like the big topics so far. Anything else that we know about parallel?
Can you have parallel curves?
You can have curves that don't intersect, so they would actually be called a transformation of each other. They're not really parallel. Parallel's reserved for straight lines, so good word, by the way. You can have curves that that don't intersect, so they're just what they're called a translation from each other. But I mean, they wouldn't intersect, so you could have something like this, like that type of thing. They're just translations. Like it's just we're gonna look at that in the next chapter. But you can take any picture you want and just like add forward to it, and it just slides it up. So then they're not really parallel, but they're not intersecting. Okay, that type of thing. It's a good concept. I like the idea. Anything else? That was really good though. Yes, you're on your A game today. Okay, you nailed the big bullets, right? They don't cross, they're on the same slope. The other big thing is that they have to be on the same plane. They're contained on the same plane. Now, we have a word for that from geometry class. It's called coplanar. Put that in air quotes. They're coplanar. They have to be on the same flat surface because you could have lines that are in different planes, like my marker board versus your paper, that wouldn't intersect, but they're not parallel. So like, because I could have a drawing up here, a line that's up on the board, and you have a line that's on your paper, and they're not touching. They'll never intersect. Does anyone know what that means if they're on different planes and they're not touching? Starts with an S. You had me excited, like you're gonna nail this. You guys kind of impressed me so far.
Symmetry, no.
Oh.
That's not it.
Supplementary.
SK.
Skew.
Skew, yeah. Skew is when you're on a different, you guys are on. So, you have a line, and then you have another line on like a different plane somewhere else, like this plane over here. And they're not going like the same direction. They're kind of like facing different directions, but they're not crossing either. They're not like railroad tracks. They're going different directions. That's skew. We have to be on the same plane for parallel lines. They have to have the same slope, everything. So that's like a big deal with parallel, that if you had a line, let's say, I just pick a couple points here and drew a line between them. Alright, so there's my first line. What is that? 1, 2, 3, 4, 5, 5 comma 4, and that is 0 comma 1. That I could have a parallel line to that thing anywhere I want, as long as I have the same slope. That's really all I need. So I could start anywhere. I could pick any coordinate on here. So you pick a different coordinate that's not those two for sure.
1, 3.
1, 3. Okay. 1 comma 3. So yeah. So right here, that's 1 comma 3. We could draw a perfect parallel line to this red one without eyeballing it, if I just knew what the slope was of the red line. Because this was like a big bullet here. You had to have the same slope. So I'm gonna find a slope for that. So I'm gonna do the average slope that we just talked about a little bit ago. I'm using the, 5 comma 4 and 0 comma 1. Using those two coordinates to find my slope, that's the red line. So I'm gonna go 4 minus 1, because you have to subtract the y's, 5 minus 0, so I'm getting a 3 over 5. So that's my rise and run. So from here, I could rise 3, run 5. 1, 2, 3, 4, 5. Rise 3, run 5. 1, 2, 3, 4, 5. And they should be parallel. Okay, that concept. All right, questions on what parallel means though?
You have to have 3 points.
2. I mean, I just picked 3 just so you can see how long it was. Yeah. Now, the thing that I want you to know from this is we've been doing equations all week. So now that you know what parallel means, the basic definition, we could write an equation for the blue line. Because you have a slope, you have a coordinate that's on it, at least one. There's more, I picked 3, I guess. But you have a coordinate, and you could immediately go into the different formulas. So slope, intercept form, point slope, I go to point slope. Standard, general, you can go into any of those forms. All right, questions at all about what parallel is? Okay, the last term I want to talk about is perpendicular, and then we're going to be done. All right, perpendicular now. We'll go back to this red line here. All right, perpendicular lines. Today I just want to talk about the definition. Tomorrow we'll do all the the formulas for it. What does perpendicular mean?
90 degrees.
Okay, it has to do with 90 degrees, right angles. I agree with that. So 90 degrees or right angles. What else? Has to deal with that.
Intersect.
Ooh, there's a good term. They have to intersect. Intersecting lines. So lines that cross. What else?
They have opposite slopes.
Good. Okay. It's not just an opposite slope. You're correct. That's half of it. It's an opposite
Negative.
reciprocal slope. The opposite is the negative. That's what covers the negative. The reciprocal means you flip a fraction over. So if you knew your slope, like that slope that I had earlier for the red line, my slope for that one was 3 over 5, I think, right? That was the rise and run that I used. My perpendicular one is I would flip this over and then make it negative. I don't care where you put the negative. It could be top or bottom, it doesn't really matter. Now, if it was negative, it would turn positive. Okay? What else about perpendicular?
Coplanar.
Ah, thank you. Good. Big key there. They have to be coplanar. They have to be on the same flat surface. So, if I picked a point, let's say I did 1, 3 again. That was the point that you guys picked earlier, 1, 3. I could draw a perpendicular line to that because I would use the opposite reciprocal slope. So drop 5, run 3. Drop 5, run 3. And this would be perfectly perpendicular. And notice I put a little box in there. The box is a representation of the right angle. Okay, questions what perpendicular is. Now there's a ton of vocab words for perpendicular. I think I'm gonna save that for tomorrow because I don't want to take any more of your time to read too much. You have the rest of time today where you can work on your assignment, the page 175, 188. Giving you like 15, 16 minutes here, actually 17, to kind of work on this. Take your time. Remember, you have to graph every single problem. Even though the book doesn't say that, I do want you to graph every single problem that I assign. And then on certain problems on that second page, you have to give me the equations in certain forms, like standard or general. So hopefully you're kind of looking at that. I think the video from yesterday isn't online yet. I'm thinking about uploading it. It should be on before the end of class. I'm hoping that I can attach it. I was having a problem with it this morning. I think I got it clear. Okay, so there you go. Rest time is yours. Remember, when is that assignment due?
Tomorrow.
Tomorrow. Keep that in mind. All right, go.
Today.